Welcome to Study Loop.
This question asks us to calculate the equilibrium constant at 298 Kelvin for this particular equilibrium, given these two individual reactions. So we first need to determine our delta G for this complex, or for this complex reaction, where we need to rewrite our equations up here to match this chemical formula. So the first reaction needs to be flipped because we have this HbO2 in the reactants, and over here it's in the products. So we'll rewrite this as HbO2 yields Hb plus O2, and this delta G is going to get flipped, so it's 70 kilojoules. So positive 70 instead of negative 70. This second reaction can stay the same because we've got a CO2 in the reactants here and here, and this CbCO, or HbCO, I'm sorry, and an HbCO in the products over here. So we'll have Hb plus CO yields HbCO. And this delta G remains the same of negative 80 kilojoules. Now, if you cancel out this reaction, you can cancel the Hb, so you're left with HbO2 plus CO yields HbCO plus O2, which is this reaction given to us. And this delta G total, if we sum this up, our delta G is going to be negative 10 kilojoules. Now, in order to calculate our equilibrium constant, we need to know a particular equation, so that's KEQ equals E to the negative delta G over RT, where R is 0.00834 kilojoules per mole. You've probably seen this as 8.314 joules per mole, but we're just converting it to kilojoules for ease. And then the temperature is in Kelvin, so that's 298 Kelvin. We put this in as our KEQ equals E to the negative 10, so I'm just going to say 10 kilojoules over RT, so that's 0.00834 kilojoules per mole times 298 Kelvin, and our KEQ is going to be 56.8 approximately. Doing this math out.